Three charges are arranged as shown below. You have Q1, Q2, and Q3. The magnitude of Q1, that is this charge, is 4 microcoulomb. Its sign is not known. The sign and magnitude of Q2 are yet to be determined, so we don't know anything about Q2. Charge Q3 is a positive charge with a strength of 2 microcoulomb. The net electrostatic force on Q3 is measured to be purely in the direction of positive x-axis, as shown by that F. Find the signs of Q1 and Q2, the magnitude of Q2, and also the magnitude of the net force F on Q3. The first step is to determine the signs of Q1 and Q2. There are 4 possible combinations. Possibility 1, both are positive charges. Possibility 2, both are negative charges. Possibility 3, Q1 is a negative charge, Q2 is a positive charge. And the fourth possibility is Q1 being a positive charge, Q2 being a negative charge. Let's look at the first possibility. Let's assume both are positive charges. Since we know Q3 is also positive, Q1 would repel Q3 in that direction, and Q2 would repel Q3 in that direction. What that means is the net force on the charge Q3 must have a positive y component. But the net force on Q3 is purely horizontal, so this cannot be. Let's look at the second possibility, both being negative charges. What that means is Q1 would attract Q3 towards it, like that, and Q2 would attract Q3 along that direction, towards Q2, which also indicates a net force on Q3 along negative y-axis direction. Again, we know since the net force on Q3 is purely horizontal, that cannot be as well. Now let's look at the third possibility, Q1 being a negative charge, Q2 being a positive charge. That means Q1 would attract Q3 in that direction, and Q2 would repel Q3 in that direction. What that indicates is the existence of x component in the net force, and this x component is heading this way, which we know not to be the case because the net force on Q3 is heading rightward, so this cannot be the case as well. That would leave us with the last possibility, namely Q1 is a positive charge and Q2 is a negative charge. Under the scenario, Q1 would repel Q3 along that direction, and Q2 would attract Q3 in that direction. This would mean that the net force would have a positive x component to it. And also, since the y component of the upward force is going that way, and the y component of the lower force is going that way, there is a chance for cancellation. So there we have it. The sign of Q1 is positive, the sign of Q2 is negative. So we have answers to part A. Now let's determine the magnitude of Q2, the strength of that charge. To determine that, let's write down the net force on Q3 due to Q1 and Q2. Let's first determine the first contribution, namely the force on Q3 due to Q1. Let's call this contribution 1, 3. The magnitude of the force exerted on Q3 by Q1 is given by the constant K times the product of Q1 and Q3. We know Q1 is 4 microcoulomb, Q3 is 2 microcoulomb, so that would be 8 times 10 to the power minus 12, because 4 microcoulomb is 4 times 10 to the power minus 6, and 2 microcoulomb is 2 times 10 to the power minus 6. When you times these two numbers, you get just that. Divide by the square of the distance between them. distance between them is 4 centimeters, so 0.04 meter squared. Now we need to compute the components. Now the force is heading that way. So that is the repulsive force on Q3 due to Q1. It has both x components and y components. So let's calculate the x component. Now this angle is alpha. It's the same angle here, alpha. This is a right angle triangle because this side is 4, this is hypotenuse 5 cm, and that is 3 cm. That would make this angle 90 degrees and this triangle a right angle triangle. So that means this angle here is 90 minus alpha. So the x component of that force is this number times cosine of alpha. So cosine of alpha I hat. The y component is going in that direction, and that is this number times sine of alpha. So that is y-axis. So the y component of that force is that magnitude of that force times the cosine of this angle. A cosine of that angle means the sine of that angle, which is sine of alpha, and it's going upward, so it is sine alpha j hat. From this triangle, we know cosine alpha is a 4 over 5, this over the hypotenuse, and sine alpha is 3 over the hypotenuse, so it's 3 over 5. So we have substituted these numbers here. Next, let's determine the second contribution to the net force, namely the contribution 2-3. That is the force exerted by Q2 on Q3. The magnitude of that force is constant K times the product of the two charges, Q3 and Q2. Q3 is 2 microcoulomb, and Q2, let's assume it is Q2 microcoulomb. So we want to determine the value of Q2. So together you get 2Q2 times 10 to the power minus 12. The distance between Q2 and Q3 is 3 cm, so over 0.03 squared. So that's Coulomb's law in action here. Now let's calculate the components. Now we're dealing with an attractive force. Q2 would attract Q3 along that direction. So this force has x component and y component. The x component is this number times cosine of that angle, and that is 90 minus alpha. Cosine of 90 minus alpha, it is just sine of alpha. And sine of alpha is 3 over 5. So 3 over 5 I hat, because the x component of this attractive force is going in that direction. We are taking this direction to be positive x-axis direction with a unit vector I hat. That direction is the positive y-axis direction with a unit vector j hat. This force also have a negative y component going that way, and that is given by this number, this magnitude, times cosine of that angle. Now that angle, again from trigonometry, is just alpha. So cosine of alpha is 4 over 5. So we write minus 4 over 5 j hat. This minus sign is because the y component of the force is heading downward. Now we are ready to answer part B, the magnitude of Q2. This net force is obtained by adding this term to that term. So when you add the two terms, you should get the force F, which is the net force on Q3. We know the net force on Q3 is purely horizontal, so there should not be any j hat term in it. What that means is when you add up the j hat terms together, they should give you 0. They should just vanish. So let's do just that. K8 times 10 to the power minus 12 over 0.04 squared 3 over 5, so that is this j hat term right there, plus this j hat term, which is a negative number, minus k 2q2 times 10 to the power minus 12 over 0.03 squared 4 over 5, they should sum up to 0. So both terms have k in them, so k would go away. This 10 to the power minus 12 would go away. This 5 would go away. And you can solve for q2. When you solve for q2 from this equation, you will get the following number. q2 is 1.6875, and the unit is microcoulomb. And that solves part B. Now part C. Now we know that the net force F is given by the sum of this number and that number only. So the net force is given by K 8 times 10 to the power minus 12 over 0.04 squared times 4 over 5 I hat plus this number right there, Q2 times 10 to the power minus 12 over 0.03 squared times 3 over 5 I hat. The number Q2 has been evaluated. Right there, it's 1.6875, and we can substitute that in here to get the net force F. And when you do that, you would get F equals to 56.25 I hat newtons. That means the magnitude of the net force F is 56.25 newtons. And that solves the problem. Thank you for watching.